How are you doing, sir? Last week, I believe that you what?
I wasn't here last
Yeah, for Easter break, you went out somewhere. Okay. How are you doing at school? I know the disaster unit is taking in, right? You did the quiz. Okay. Just the quiz itself. Okay. All right. So just to make sure my. Okay. Let's stop. Okay. So great. So, did you guys start to learn about trigonometries? Not yet. You're doing word problem with sine law and cosine law. So you're learning sine law and cosine law. Yeah. And then, did you learn the special cases? Oh, yeah. Not special, special angles, special cases in sine law and cosine law. All right. So, good morning. So, how are you? What you're learning at school? Where are you in trig? What advanced ratios you doing?
I'm not sure. We only started.
What do you mean you're doing advanced ratios? There's only 6 ratios, sir. There's no such a thing as advanced ratio. Sine, cos, tan, you flip it.
Yeah, we did that.
Did you learn exact values? What? You didn't learn special triangle, 30, 60, 90 angle, 30, 60, 45, 60. I mean, 30, 60, 45, 90. And then, now what your advanced stuff look like? How about you? Where are you at school? You start trigonometry, and then you finish exponential functions. Okay, did you write a test on it? Yeah. How did you do it? And how about your updated marks look like? Harsha? Oh, there's no update after midterm. All right, so we are working on finding the finding the special value, special angle. But I'm going to continue my lesson today. How we should be able to find or solve for the unknown angles if the ratio is given. So that is something I'm going to get started with. The trigonometric ratio of angle between 0 and 360. It's called solving for trigonometric equation. So we're going to see how we should be able to do it. And then we'll be going back to trigonometries. All right, so let's going back to see. They're given a ratio, and then you want to find out for angle of theta, sine of theta is negative root 3 over 2. Let me see who joined online. You said Divya online?
Yeah.
How are you doing at school? Where are you at your math?
I'm doing periodic functions.
Oh yeah, that's the next unit.
Yeah.
And you're done with the trigonometry test?
Yeah.
Okay. But before I move on, I can warm up yourself. I know you guys didn't do the homework. That's okay. That's perfectly fine. Let's do that question P. Find the exact value for tan 30 minus tan 60 divided by 1 minus cotangent 45 secant 30. In case you forget all the ratios, I'm going to be write my ratios again. At this point, I'm expecting you know the ratios by heart. 0, 30, 45, 60, and 90. Sine, cos, and tan. Either you memorize or you remember my table. You can go in both directions. Sine of 0, 0, 1/2, root 2 over 2, and root 3 over 2. That is going to be 1. We reverse it. 1, root 2 over 2, root 2 over 2, 1/2, 0, tan is 0, root 3 over 3, 1, root 3, undefined. So I can help you with the chart, but you're expected to know the chart. So using the chart, you don't have a trigonometry, sir? You never come to my trigonometry lesson? So both lessons. Oh yeah, New Year, Tamil New Year, you didn't come. Okay, I can print that. Just give me a moment. All right, these guys can go. Mhm.
Cos 30 degrees. Is that 3/2?
Root 3/2. Are you sure I didn't print the handout?
I only have
How about 10?
Not 10. It's not 10. It's 10.
10. I said that.
Yeah, tan 30 degree. Root 3/3. Let me print that chart. How's your buddy doing, man? You don't see him? Does he exist? Chapter 5, handout.
Sorry, does the last degree say 80 or 90?
90. Could you have this on your notebook?
Yeah.
So why don't you take that from the notebook? Oh, yes, you're here. How are you doing, sir? All right, I can put you in the front. So just move this little back. Yes, Kaushi, just move the chair a little back. Perfect. Okay. How was your Easter break? Good? Had a great party? Party at home? So the US president went to see the Pope, vice president went to see the Pope, and he killed him. You guys know they didn't go along with each other, right? Because Pope says that Jesus Christ is also a refugee, and he didn't like the statement. What is happening in world tomorrow, Canada tomorrow? Asha, what's happening in Canada tomorrow? What's happening in Canada tomorrow? What? Oh, federal election. Okay. Oh, what? I voted for Mike Garney. Mike Garney. Right? Which party is that? I voted for Dr. Carney. He has a PhD in economics from Oxford. I voted for the most educated prime minister we can elect ever. He's the current prime minister of Canada. Who's the prime minister of Canada? Huh? Who's the prime minister of?
Orange party, red party, green party.
No, my question is who's the prime? My question is who's the prime minister of Canada? Okay, so fastest to back. All right. So let's see how do you guys do that exact value. Oh, I should give my grade 9 question I gave to my grade 9 class to see if you can do it. Now calculator. You're not all use. These are non-calculator. These are non-calculator questions. Okay, let's see what did you do for tan 30, you substitute, tan 60, you substitute. Okay, so simplify that. Let's see if you have substitute. All right, so you substitute, you have substitute times one place is not correct. Secant 30 is not right. All right, let's see how do you guys substitute in the value correctly on the new equation. Okay, let's see if you have substitute the values correct. Oh, tan 30, tan 60. Okay. How about you, sir? Did you simplify or do you flip the pages together? Substitute, and what's next? Where do you get that, sir? Cotangent 45. Where do you get? There's no place on my chart I have cotangent 45 that value. How did you get that? Huh? All right. So this is just to warm up yourself. Tan 30. So what is tan 30 is? Root 3/3. What is tan 60? Just root 3. Divided by 1 minus. Cotangent 45 is basically equal to 1 over tan 45, isn't it? What is tan 45 on my chart? 1. Secant 30 is 1 over cos of 30 degree. What is cos 30 degree? Root 3/2. 1 over root 3/2 is 2 over root 3. Okay, that is 2 divided by root 3. Now we had to simplify. You cannot leave like that. So there's a numerator, there's a denominator. So it's root 3 minus 3 times root 3 over 3. So that's I simplify my numerator. Now let's do this divided by root 3 is the least common multiple. So that is going to be root 3 minus 2. Because this is division sign, I'm dividing. Root 3 minus root 3 over 3 time. Division is going to be going back to multiplication. So we're going to get root 3 times 3 root 3 times it by root 3 over 3 times root 3 minus 2. I'm going to open the bracket. Root 3 times root 3 is 3. Root 3 times root 3 is 3. And then 3 times 3 is going to be 9. Over 3 times root 3 minus 2. Negative 6 over 3 times root 3 minus 2. I can simplify that. It's going to be negative 2 over root 3 minus 2. Now, the sad news is your answer is going to be not on that form if you check the answer. Why the answer is not going to be on that form? On your denominator, you have a square root, isn't it? So technically speaking, we don't really want to leave the answer with a square root on the denominator. So we did talk about what we're going to do. We're going to multiply something called a conjugate. So what is a conjugate is? Simply the same expression with a plus sign. Same expression on the denominator with a plus sign. And then you can see I'm multiplying my numerator and denominator by the same expression. That means I'm not really making any changes, isn't it? It's simply multiplying by 1. Now, let's keep my numerator as it is, but think about the denominator. Root 3 minus 2 times root 3 plus 2. How that look like, Aaron? Can you recall that format?
0.
That's going to be 0. Root 3 minus 2. We're talking about this guy in the denominator. Root 3 minus 2 times root 3 plus 2. How that look like? The one I highlight. These two product. Difference of squares. A minus B. A plus B. Oh, yes, by the way, how are you doing in the math?
I have a 95 right now.
On a midterm?
Yeah.
You got a midterm report card? How's the classes doing?
That's good. Median's 80.
Well, you're on the top of the median. So your class is not doing great. Okay. So does everyone see that A minus B times A plus B? So that's going back to caveat. What is A minus B times A plus B is equal to? If you multiply A minus B times A plus B, what did you get? If you multiply A minus B times A plus B, what would you get?
A squared minus 2ab is b squared.
Why, sir? Why? Okay. What would you get? A minus B times A plus B. Oh, she.
A squared minus ab.
What would you get? Yes. I think I'm going to quit my teaching, going back to school, apply to my faculty of education, do my probably master's and PhD in math education and math struggle in Ontario. and try to find out what's happening. It's been taught in the same way. There's no magical thing is happening.
A squared minus b squared.
A squared minus b squared. On the head that you open it and then you expand it, that's what you did, sir? Why don't you guys remember that it's simply a squared minus b squared, difference of squares? Isn't it? Right? All right. So root 3 times root 3, yes, root 3 squared minus 2 squared. So minus 2 times root 3 plus 2. Root 3 squared is 3. 2 squared is 4. Two times root 3 plus 2. All right. So that's just to warm up the exact values. So I'm gonna moving back to now this piece. Find the value of theta. So how we're gonna find the value of theta? I'm gonna show you one example. You guys gonna follow the rest. Step one. Step one. Forget the sign in front of the ratio. In front of the ratio. Look at the exact value table. Exact value table. I didn't print that.
No, we have up to date.
Oh, I only print up to day 3. All right. All right. All right. So I print up to day 3. So I did this. I see. So that is page 21 to 41. Can you check that little staple back? Stone right here. You have paper inside? Yeah, grab all of them. I think that should be enough. So 1, 2, 3, 4, 5, 6, 7.
Printed it for me.
Yeah, 1, 2, 3, 4, 5, 6, 7. Ignoring you, sir. I need to print from page 21 to 41. Okay. So that's 5 pages. So I have enough pages to print that. Okay, perfect. Otherwise, I need to go upstairs to get. All right. So while the printing coming out, we're gonna going back to see how to solve this. Forget the sign. Yeah. Forget the sign in front of the ratio. Look at the exit value table for sign and find the angle that gives root 3 over 2. So can you look at the table and tell me 60, correct? And we're gonna let that as an alpha. We're gonna let that angle as alpha. This alpha is known as your related acute angle. Related acute angle. That's the first step. Simply forget the sign, look at the table, find the angle. You don't need to write the step. So all I'm gonna do is, I'm gonna just keep that for my reference so that you can copy it. The next step, step two, draw the possible terminal arms for the given ratio. So what does that tell? This time you had to look at the sign. So that's going back to other right. In which quadrant are the right sign is negative? Quadrant 3, yes. So I'm gonna call that theta 1, yes. 2, 4. You see that picture? Any question on that step? Now, theta 1. You know it's in the third quadrant, isn't it? Any angle in the third quadrant can be written as 180 plus the alpha. Any angle in the fourth quadrant can be written as 360 minus alpha. So what is my alpha? Alpha is 60 degree. So 120 degree. What is my alpha? Alpha is 60 degree, which is going to be 300 degree. So what are the possible angles for theta? 120 degree, and 300 degree. Are you guys following that? All right. So if you guys got it, I'm gonna give a very similar question, but let me get this printout so far to give it back.
But it should be 180 plus 20.
You're right, sir. 180 plus 60, so 240. You know what happened? It doesn't print that page. It's print everything in there. That's okay. You guys gonna copy it. It has a practice questions. It's actually printing from the practice question. That's good. You guys can copy that for your reference on your notebook. Pass this. And then let's just go behind. Day two, day two, day two, day two. All right, all right. Oh, wait, what's this? Yeah. Huh. Somehow. Oh, well, let's just start from here. We're gonna get 3 copies. Okay, here we go. Print 8 copies. So you gotta get. You don't have it, and you don't have it. Do you have it? You got one? All right, so 1 copy is missing. I should have my paper. Okay. There's no paper there, right? It's gone. All right, just give me a moment, guys. Let me grab the paper too. Do you have a midterm report card coming in, sir?
I don't know when it's coming.
Would you know what your Mr. Marks for the second math course you're taking?
Not yet.
Okay. Yeah. Oh, this. I had this. Fix it somehow. Okay, let's give it my dad. I need to print 1 more copy. How many you have multiple session of classes for your grades? Multiple session means same math course running in same time with the different teachers. You? Do they use the same testing quizzes?
No.
Different? How about you? Different? All right, so let's going back to there. So I did this, guys. So I'm gonna be asking you guys to do one example on your side. All right, so you guys need to copy this. This is not printed, but it's only printed this page. So I'm gonna give you, if you understand it, I'm gonna give you next question. You guys gonna do sine of theta is equal to -1/2. Anyway, and then Divya, you're gonna do on a piece of paper. I'm gonna be asked. You can send me the text message so I can see it on WhatsApp. What?
Okay.
All right. So one last of this. This is for Gaussian, isn't it? All right. So can you guys do sine of theta as -1/2? Just follow all the steps I show. I show you. I'll keep the step here. Forget the sign. Look at the table. That is your alpha. Draw the diagram. Where does terminate? And find the angle. Hi. What's up? Are you doing the work? You done? So, what are you doing? Huh? I know. You done, sir? Did you do the work or just mental math? Only one angle? Right. The pencil? Yes. Okay. Very dark, very light. That's right. Right. That's right. Let me see how you guys doing. You done? Mental math. You got the angle right. Then you need to ask yourself, because right now the ratio is -1/2, right? So which quadrant sign is negative? Cast quadrant 3 or 4, yes. So just you're going to label that, and then the way I calculated, you're going to calculate. Let me see, sir. You done? Okay. So you're still thinking?
Yeah.
So a couple of you have a notebook, a couple of you just writing here and there. Why don't you have a notebook? What?
I used up all of it.
What did it say?
I used up all of it.
Okay. All right. So we're gonna looking at a theta, and then we know the alpha is 30 degrees. That's on the chart. Then we draw the terminal arm. Sine is -θ1, sine is -θ2. So θ1 is equal to 180 plus 30. θ2 is equal to 360 minus 30. So θ1 is going to be 210 degree, and then θ2 is equal to 330 degree. So pretty straightforward. Now we're gonna going back to apply that for a little complicated one. Now they give cotangent theta. Well, there's no way you can look at a table for cotangent. My table doesn't have anything with a cotangent, but we know cotangent is what? 1/tan, isn't it? So therefore, tan of theta is equal to, you're gonna flip it, 1/√3. In case you don't know what is 1/√3 is, it's actually √3/3. Can you just complete that? Yes, you're done. Just wait, sir, wait. Same strategy. Forget the sign. This time is positive. Ask yourself where is tan is going to positive. Find the alpha. So let's see, what is the alpha in this case? Alpha. On your table, for what angle up? Tan. You got tan is √3/3. Huh?
60.
from your table.
Oh, I think I wrote it wrong. Can you see the 724?
Yeah. Good enough? What angle of tan is going to give you root 3 over 3 from the table?
60? I mean, sorry, 30?
30 degree. Don't you have the table?
Yeah, I do.
Okay. Then you should be able to get the answer pretty straightforward. So let's go back to Tivia. Tivia, what did you get? Tivia?
For theta,
I'm talking about, yes, the B.
tan is 30, theta is 30 degrees and it's 210 degrees.
Correct. So what you guys got? What do you got? What do you got? So you got 120. But 120 for tan is going to be a second quadrant, isn't it? In second quadrant, tan is negative though. Because we're looking for the positive angle, isn't it? So tan, according to the CAS rule, only positive first quadrant and the third quadrant. First quadrant is something you already read it. Somebody already say it. That's exactly the alpha. So in first quadrant, your theta and alpha will be the same, which is going to be 30 degree. The next one, if I roll the terminal arm, this is moving back to the third quadrant. So this theta is going to be 180 plus 30 degree. That's supposed to be 210 degrees, isn't it? Yeah.
For the first question, you got quadrant 1 as 210 and quadrant 2 as 230. But then on the other side, you put 120 and 300.
Which one?
You got 210 and 230.
Mhm.
And then when you put it beside the question, you put it
Beside which question?
120 and 300.
That's a different answer question though, because that is negative root 3 over 2. This is negative 1/2. Different ratio. Make sense? Okay. All right. Now we're gonna moving back to question like this. Question like this. How are we gonna do it? Same strategy apply, but Gaushi, on your table, do you know what should be the alpha? No, we don't, because it is not part of the exact value, isn't it? All we're going to do is same process, forget the sign. So in this case, it's positive. We will do calculated to find out the angle. Cos inverse of 30 over 50 will give me the angle. So that will give me the alpha. What is the alpha you got, Harsha? Cos inverse of 30 over 50. Oh, hold on. Just wait.
24.9.
What? How much?
24.9.
Correct? So just a 74? You got 74.9. What did you guys get? 74.9. So that is 74.9. We're going to make it 75 degree, not a big deal. Now, what do? We ask ourselves where cos is positive. Theta 1 in quadrant 1, theta 2 in quadrant 4. Theta 1, obviously, the angle alpha. Theta 2, 180, 360 minus 75. 60, 300, another 15, 285. So if you guys understand this, well, I will do the next one for practice, so then you can do the other question for practice. So this one is very similar to this guy. There's no way from your table you can read the exact value, isn't it? But unfortunately, this is 1 over cos theta. So negative 1.4396. So what is cos theta is equal to? We flip it. We simply flip it. That's the first step, right? Now, forget the sign, find the angle alpha. That is going to be cos inverse of 1 divided by 1.4396. You see that? Forget the sign of the ratio and find the angle, because 1 over 1.4396 is not on the table, isn't it? It is not on the table. You cannot find that from the table. Now, let's see who can give me the alpha. Good job. Let me see. What did you get for the alpha, sir?
You know how to change it from radian to degree mode?
You keep it on radian, Mark?
No, we started radian. That's what we did. I didn't.
Then you should know how to change it back. Okay. So come over here, sir. So you go to mod, and when you go to mod, sometimes the mod will give you. So a mod doesn't give you, then we're gonna moving back to what is the shop. So there should be on the table, there should be degree. If this is not degree, so you get an alpha. Format 10. Just checking all the table. Decimal, GCD. Oh, do you have a ZCD function? Really? And then they don't care about what calculator you use?
I don't know what that is.
You don't know what is GCD is? Okay, that's fine. So alpha doesn't give me any mod. So mod, let me see what mods I have. So if I go to 0, normal mod, that won't change my degree. Mostly couple of, oh yes, it's here. Shift this. That's radian. I need to type it again. So shift. No, that's a different function. I'm checking everything on the top. Well, then I need to check for that menu. Mostly, oh yes. So here we go. They have the shortcut to see how to change it back. Let me just make sure I'm sharing the screen. So number one. Where's the setup button? Oh, it's here. Degree. Gradient. You need to press it a couple of times. Gradient. What I did. Oh, shift. Degree. Here we go. You press shift. That will change back to radian. Shift. That change back to gradient. Shift. Now. So right now it's degree master. So you know how to change back to radian. You press that, that's changed back to radian, and then it's going to mean radian. Okay. Do you guys know what we're talking about? So in grade 12, your angle will be measured in different terms, radian. So if you let your calculator for your grade 12 student, and then you're using it, grade 12 student change it back to a different mod, and then you'll be getting all wrong answers. So you need to make sure your calculator display on the top DRG. If your calculator doesn't display DRG, then your calculator is in a wrong mod. There are 3 mods possible: RAD, DRG, GRAD. After grade 11, you will forget degree. You completely forget degree. You're not going to work with degree. You're only going to work with radian measure. All right, so let's go back to Kavya. What did you get for alpha? Has everyone got 46 degree? Cool. Then what we're going back to the table. Cos is negative in the second quadrant, cos is negative in the third quadrant. So theta 1 is going to be 180 minus alpha. You can do the math. Theta 2 is going to be 180 plus alpha. You can do the math. You're following that? Okay. Okay. So there's one more question. So I have to complete it so that you can do the practice. Tan theta is root 3. But this time, you had to be really careful. This has changed. Negative 360 to 3. You have your mobile device? You have your phone? Where's it? Are you taking the notes?
Yes.
Okay. So this one a little different. As you can see, negative 360 to 360. What does exactly that mean? Negative 360 to 360. Let's going back to break it down. We can break this one down. Negative 360 to 0 to 360. We can break it that way. So what is exactly they're looking for is, they're looking for to find the angle in this direction. They're also looking for you to find the angle in this direction, both positive and negative direction. So let's see how do we do that same process. We're going to do the positive direction first. So alpha. Audrey, what is the alpha? Not Harsha. Oh, yes, Harsha. Yes, what is the alpha? 60 degree. Now, where is tan is positive? Tan is positive here. That is going to mean theta 1. Tan is positive again in here, theta 2. So all I'm going to do, theta 1 is equal to 60 degree. Theta 2 is equal to 180 plus 60 degree, which is 240 degree, right? Now, how do I tell the negative one? Pretty straightforward. All you have to do is another possible angle. You need to go this way, negative. If you subtract 60 degree, negative 300. Another possible angle, you ought to go this way. If this was 240, another angle possible, negative 120 degree. So all the possible angles are 60 degree, negative 300 degree, 240 degree, negative 120 degree. I won't write that way. I will write negative 300 first, negative 120 next, 60 degree next, 240 next. You see that how you're doing a negative and positive angle? When you find a positive angle, yes, sir. Okay, question? All right. This is not there printed for you. So let's do some practice. So first one, perfectly exit value. Second one, not perfectly exit value. So that's being said. All right. So you guys are expert on that. I really did do all of them, but I'm not going to ask you guys to do all of them. So let's start with J. And then you guys gonna move after J, you guys gonna do L. J and L. Tavia, you can send me the picture when you're done. Let me know if I can check it. J and L.
Okay.
You need a notebook to do that. There's no space. What's up? Okay. Okay. Right, this time back to school shopping is calculators on Costco. Yes, I need to keep it like rulers. There are certain things you can't really do without calculator. Multiplying by pi, you need to have a calculator unless you know how to multiply decimal numbers. Okay. All right. Let's see how you guys working on that. Hello. He asked you to seek in that. Find it, but that's not complete. So more to do it. There's multiple possible angles using the passage. And remember, these questions are exact value. Didn't I come back on the handout?
Yeah, I didn't realize it's been 2 years.
Okay, so this worksheet that you're working on, you should not use the calculator, there's like set values. So you gotta look at the table. You gotta look at the table for what? I'm taking cost inverse, and then I'm not sure how to be taking the cost inverse because
It's not right.
this is 2/3. So you won't find it because you need to flip it, because you write 1/cos, isn't it? And cos of theta, that will be going back that way.
Okay, thank you.
Answer? And the first one? You got that? How that makes sense? You got this. So if cos is positive, the first quadrant, it's going in the same angle, man. We only do that 180 minus plus if they're going outside of the first quadrant. If it is a first quadrant, the first angle will be that. You done? So you don't get negative 62 like that. You find without the sign. That gives you 62. And then you use that to find the angle, right? But remember, this is positive, isn't it?
Oh, so I'm looking here.
So where do you think cos is positive? Which quadrant?
Please.
Yes. So those angles are not on that quadrant. You done the first one, sir? 1/cos. How come that's 60 degrees? So you had to flip it. But you're looking for the cos, isn't it?
Yeah.
So not 1/cos. If you flip it, that ratio will switch. Remember the first one? Where is it? That's right. And then you work on the second one. Okay. Let's see the other way. How come you can get 210? You're working with cos. So cos is positive on the second quadrant. You need to rewrite the cast. All right. So want to see something? Let me show this. All right. Is your school is on the list? North Shore, Niagara Falls, Agincourt. Anyone from Agincourt? No. Nearban, Unionville, Gulf, Waterloo, Markham, Barrock Secondary, Kitchener, Gulf, Brampton, Hamilton, Toronto, Denville, Agincourt, Mississauga, St. Catherine, Markham, Father Michael McGinley Catholic School. Top of the list. So top of the list, but the good news is that has been changed over the years. Do you guys know what is the negative 17.9 means? So Gaja attending Father McGinley in YRDSB Catholic School. Let's see, Gaja is in grade 12. He applying this year to computer engineering program. With 99 average, he's top of the class. His average will be considered by Waterloo only 81%. So why Waterloo do that? Waterloo look at all the students attending the engineering program from his school They look at the average they entered and compare that with how they're doing in the first year. They find a difference on the average. They applied that to the next year intake. Let's moving back to the next schools on the list. Toronto Gov, Mr. Hawkville, Eugene Code. Let's look at some beauty. Lamoureux Collegiate Institute, are they attending? But unfortunately, they didn't have that many students attend this program. It was in the past very low adjustment factor. What happened? I taught on the school too. What happened to Lamoureux Collegiate? Demographic have changed. We got some nice students to the school because I'm recording it, nice students. So no one is attending Waterloo. Let's going back to see is any schools on the list. Yeah, my school is on the top of the list, Lester B. Pearson with the 20%. Let's see. Let's see which school to Pierre Trudeau. Richmond High School. Who is from Richmond High School? Richmond Hill High School. Okay. Are you guys doing great? You guys doing not bad. It's only 12.5 adjustment. If you apply to Waterloo within 99, you only subtract 12.5 from your total average. So that means kids going from your school doing pretty well on the first year. Markham District High School should have a high adjustment factor. So let me check that out. Markham District High School. There's a couple of schools from Markham. And Markham District, Hamilton, Jarvis, Lamoureux. How Markham District's missed it. All right. Now, the other people wondering, my school is not in the list. So my school is doing fine? No. If your school is not in the list, by default, they apply 20% adjustment factor. Sorry? No, that's the last page. Now, the question here is, will that apply to all the program? The top-notch program, not for all the programs. They don't apply to life science. They don't apply to biochemistry. They don't apply to criminology, psychology. They apply to any engineering program or any computer science program or software engineering program. Now, you guys may wonder, like, where did they get this list from? So what happened? People who actually couldn't able to get into Waterloo program, they applied. The admission was denied. They sent an email to Waterloo admissions office. Using a freedom of information, they can request this information to be published, and then Waterloo publish every year. That's clearly tell if you belong to this school, this is an adjustment factor. That's why you didn't make it. Now, if there's no students have attended, you can see that, for example, Anaha School is not in there, and then Markham is default 20%. So why do they do that? They know school-based test. There's always an inflated box comes in somehow, right? And sometimes teachers are not strict enough in terms of assessment. And then as I get taken charge there at school, yeah, we keeping the assessment in the high standard. We know we have kids taking private school because they find it, they can keep up with the assessment we're doing in our grade 12 class. But private school, Waterloo will simply reject. They don't care. I mean, for the competitive program. So, as the other schools are doing it, they do. But do they publish? Not all the schools. I'm not going to say Ryerson will do that, TMU or Ontario Tech. But schools like University of Toronto have their own way of filtering out. So, publish each year. If your school is on the top of the list, you need to know what to do, right? All right, moving back. So secant of theta, some of you did it correct, some of you didn't. So secant of theta is going to be 2 over root 3. So we rewrite that as 1 over cos of theta. We have to flip it. Some of you didn't do that. Root 3 over 2. Now positive. Where is cos is positive? Cos is positive on the first quadrant. Cos is positive on the fourth quadrant. Theta 1, theta 2. We find the alpha. I know the alpha must be 30 degrees. Theta 1 must be 30 degrees. Theta 2, 360 minus 30 degrees, which is going to be 330 degrees. Are you just following that? Okay. I'm giving you this worksheet. There's the answers on the bottom. I know you don't do that practice because you don't have a time, right, Aaron? Everyone don't have a time. That's okay. Everyone is busy on the election. All right, we're gonna moving back to the most annoying part, trigonometry identities. So what is identities about? Identities are like equivalent expression. Equivalent expressions. So let's going back to something related to algebra. Show that, if I say show that 2x plus 5 whole thing squared is equal to 4x squared plus 20x plus 25. How would you do that? If I asked to show that, what would you do, Harsha? Okay, you can do that. You can factor it. But say another way you can do it. What is another way you can do? She said you can factor it. Exactly, you can expand it. We can say there's a left-hand side of the expression and the right-hand side of the expression, isn't it? So what does the left-hand side of the expression say? 2x plus 5 whole thing squared. So then we write it 2x plus 5 times 2x plus 5. Then what do? We expand it by using the FOIL. 4x squared plus 10x plus 10x plus 25, which is going to be 4x squared plus 20x plus 25. And then we were able to show that's on the right-hand side. Do you guys see that? Yes. As Harsha said, you can go in both ways. Doesn't matter. I can still take the right-hand side to show the left-hand side. Left-hand side, show the right-hand side. Pretty easy, isn't it? We're going to do that in trigonometry. That is what we're going to learn. So let's get started with what we're going to learn by looking at a right angle triangle. It is not there. I want you guys to copy the right angle triangle. A, B, C. Let me mark this angle as theta. So in terms of A, B, and C, Kavya, what is sine of theta is equal to? In terms of that A, B, and C, how would you tell sine of theta? Yes, sir. Mm-hmm. Using that, what is sine of theta?
AC over AB.
AC
Oh,
over.
BC over BC.
Correct. Opposite over hypotenuse, isn't it? Are you seeing that? All right. I don't need to recall Sol Cato. So you should know what does CAT stand for. Let's going back to Anaher. What is cos of theta is equal to? I know. But what is that in terms of the letters? We will say BC. All right. Tan of theta. What is tan of theta is equal to, Adrai? So, Cato. I'm waiting. It's going to be that the Tamil movie that came out, Good Bad Ugly. If you guys, has anyone watched the movie? Ajit Kumar? No? I'm waiting Nanba. Okay, that's it. In there, the Ajit Kumar will be telling, keep on telling, I'm waiting Nanba. Just referring to Vijay's to come to politics. Okay, I'm waiting.
What's opposite over adjacent?
Yes, what is the opposite side for theta? What is the adjacent side?
AC
AB. We will go by alphabetical order. All right. We also going to write tan of theta. So what is tan of theta, Gaushi? Oh, I did a tan of theta. My bad. We're going to go cosecant theta. What is cosecant theta?
BC over AC.
Thank you, sir. Aaron, what is secant of theta?
BC over AC.
AB, sir. You flipped that cos. I already wrote the cos, isn't it?
Yeah.
You flipped it. Okay. Cotangent of theta, Javier. So far, so good. All right. Now, in triangle ABC, by Pythagorean theorem. We know AB squared plus AC squared is equal to BC squared. Anyone disagree with that? Anyone disagree with AB squared plus AC squared is BC squared? All good? Pythagorean theorem. AB squared plus AC squared is BC squared. I'm going to divide this all side by BC squared. That's my first step. We can do that without further issues. You're dividing by the same factor. We're going to rewrite this AB over BC whole thing squared plus AC over BC whole thing squared. Karsha, what is BC squared divided by BC squared will be?
Just AC.
BC squared divided by BC squared. Aaron,
Wait, which one?
BC squared divided by BC squared.
Would it be a
How's she?
Would it just be BC? 1.
1. It's the same expression, isn't it? BC squared divided by BC squared. Isn't it? 2 divided by 2 is? All right. That's fine. Where does this going wrong? That's why I try to figure out. It is not grade 11. Absolutely grade 11. You're learning grade 11. Definitely something going on about math learning at schools.
not the different terms?
How come different terms? It's BC squared over BC squared. That's a distance.
Isn't it AB squared over
Huh?
AC over BC?
Let me rewrite that BC over BC whole thing squared. How about that? The way I wrote it, I take the exponent out, right?
Yeah.
What is BC divided by BC?
1.
1 squared is? 1. I just follow on that. All right. But let's look at the ratio. So, what is AB over BC in terms of the ratio? What ratio given by AB divided by BC? Cos. So cos square of theta, we write the square in between the angle and the cos. AC over BC, Kavya, what ratio is given by that?
AC.
Mm-hmm.
Sin.
Sine. Sine square of theta. BC divided by BC is 1, isn't it? Are you saying that? This is our first identity. This is our first identity. We did this one somehow last class. You guys didn't realize that we did this. But without telling us, it's an identity. How many of you remember we did this? How many of you remember we did this last class? We didn't. Let me show you what we did last class so that you know. CMC grade 11. So you were away last class. No, you were here. Yes, you were laughing the way I'm just doing it because I did a timing. Who's going to tell the answer? So measurement and trigonometry, let's going back here. So let's see if you can recall this. We're going back to the special angle. We talk about trigonometric ratios in the special angle. All right. Modulus sometimes give hiccups. Check your understanding one. Then we went back to this. So you guys don't remember this we are doing in last class? Huh? Did we do this one last class here? Oh, you are away. Did we do that last class? Yes. But no one even realized it. All the answers we got is 1 or minus 1, 1. Most of them is 1. All the answers we got last class is 1. Did you guys agree why we got 1? Sine squared of theta plus cos squared theta is always 1. Make sense? That is the first identity. Another way, if I ask what is sine squared of 66.7 plus cos squared of 66.7, without using the calculator, you should be able to tell that as 1. All right. Now, let me go back to my Pythagorean theorem again. Let me go back to my Pythagorean theorem. This time, I'm going to divide it by AB squared. I'm going to divide it by AB squared. Let's rewrite this AB over AB whole thing squared plus AC over AB whole thing squared. BC over AB whole thing squared. We can do that. We can do that. So, Anaka, what is AB over AB is equal to?
AB over AB. One.
Right. Now, AC over AB. If you look at the table, what is AC over AB is equal to, Harsha? What ratio? 10. So 10 square of theta. And then you can look at the ratio to tau secant square of theta. This is my second identity. Let me do this one this time differently. I'm going to divide it by AC squared. I'm going to divide it by AC squared. So AB over AC whole thing squared plus 1 BC over AC whole thing squared. Kaja, what is AB over AC is equal to?
AB over AC.
Cotangent square theta. So let's rewrite this. 1 plus cotangent square theta is equal to cosecant square theta. So let me summarize this. We have learned sine square of theta plus cos square of theta is equal to 1. 1 plus tan square of theta is equal to secant square of theta. And 1 plus cotangent square of theta is equal to cosecant square of theta. Did you guys see that? Everyone seen that? These are the 3 identities you're going to be used to prove things in grade 11. Known as Pythagorean identity. Now, some school, being nice, will give you the identity formula. Some schools, for example, Divya schools. Divya, did you get identities on your test?
No, we had to memorize.
No, yeah, you need to memorize it. So what you're gonna do? Sine squared theta plus cos squared theta is 1. 1 plus tan squared theta is, you can record it, listen, but eventually you will remember what you expected to know. But let's do some manipulations here. How many of you say this is correct? Let me ask. How many of you can tell? Is that true? Okay, 1 thumbs up. Is that true? Why? Why do you think that is true? Sorry? Is this is true? You're scared of math, I can say. So there's no, either you say it's correct or not wrong. That's fine, right? You need to come out of that zone. Either it is going to be true, it's not going to be true. Otherwise, it's a correct. Why? Yeah, not flipped over, we rearrange. I move that sine squared theta to the other side, isn't it? Make sense? Now, let me going back to make you guys drive crazy. Is that true? Javier? Why? How? Is that true? No, it is not true. Yes? Well, I'm just telling her response. He said it's not true. What about you? It is true. Kaja? Why? Difference of squares. 1 minus sine squared of theta. I can rewrite as 1 squared of minus sine squared of theta. 1 plus sine theta, 1 minus. Yes? Are you following that? Yes? So we should be able to rearrange this, right? So let me going back. I'm gonna say prove this. Prove this identity. So let's look at this question. So all they ask to show is you have to take the left-hand side to show the right-hand. So they'll take the right-hand side towards left-hand side. That's all they want. So let me take the left-hand side. What I got on my left-hand side? Cos squared theta over 1 plus sine theta, isn't it? Did I just rewrite that cos squared theta 1 plus sine theta times 1 minus sine theta? So can I simply replace that? Yes. Everyone agree with me? What I am dividing by? 1 plus sine theta, isn't it? Can I cancel these two because they are exactly the same expression? What I left over with at the end? 1 minus. Is that sitting on my right-hand side? Did I able to prove the left-hand side of the expression is equal to right-hand side of the expression? I didn't introduce what is identities yet. All I did, I show you the trigonometric Pythagorean identities. Then I just write some equal, yes, sir. Yeah, I wrote some equivalent expression. Then I wrote my own question. I just wrote my own question because you already see it. This is what trig identities. Now let's going back to think about this. You didn't know this one yet because I did it for you, isn't it? Now you're looking at this. You're looking at this. Now you're going to be scratch your head. What should I do with my cos squared of theta? You're all going to be going back to this expression. You see cos squared of theta. Can I rearrange for cos squared of theta? Absolutely yes, isn't it? Because cos squared of theta, I can rearrange 1 minus sine squared of theta. So when you're doing the work, what would you do? You would change that back to that, right? Now you need to know the algebraic technique. You got 1 minus something squared. You should be able to factor it out a plus b times a minus b. Here, are you following that, sir? All right. Now let's going back to proving trig identities. The problem with proving trig identities is you need to practice. There is no magical way. So we're going to be practice something so you guys will see what to do. Are you guys ready? So it's in the handout. To accomplish this way, we may, so to prove identity, we may separate the expression in left-hand side, right-hand side, simplify the more complex side, or transform both sides until they are the same. So some technique, express all tangent functions in terms of sine and cos. You can do that. Look at the expression where the Pythagorean identity can be used, which is sine squared of theta plus cos squared theta is 1, 1 plus tan squared of theta is secant squared theta. Where necessary, factored out the greatest common factor. Remember, you can only cancel expressions when they are exactly the same. So we're gonna see how identities play the role. I already did the Pythagorean identity. So I'm gonna be going back to we already proved it, but we're gonna prove it different way. So this is obviously we know. So let me show you how to do this. So I'm gonna take the left-hand side. So what I have on my left-hand side, cotangent of theta, isn't it? What do we know about cotangent of theta? What do you know about cotangent theta in trigonometry? Right? 1 over tan. 1 over tan theta. What do we know about tan theta? It's sine theta divided by cos theta, isn't it? Now, when you don't have a sheet? You guys don't have the sheet? Huh? Do you have the sheet?
Yeah.
Let me see. No, I can't remember the pages. Let's look at this. Bring this for you. Oh yeah, you got some additional pages. And then let's look. Oh, I see. All I did it. I know. I stapled it in the wrong way, but it's on the back. Now, can I move the cos theta up? Yes, cos theta over sine theta. Is that what I need to show you guys on the right-hand side? Yes? Everyone following that? Okay. Now, I already gave you this as an identity. I already gave this an identity, but they want you to prove it. So, Gaussian. What the steps in proving identities we're talking about on the summary? Like, there are certain things I listed, right? 1, 2, 3, 4, 5. So, if you have that 1, 2, 3, 4, 5, what should I do to prove B? If you have the 1, 2, 3, 4, 5, what should I do to prove B?
Express all functions as sine and cos.
Correct. Express all the functions in sine and cos. But we don't need to do that for the both sides. We're going to do that for one other side. Now, which side should I choose it based on the rule 1, 2, 3, 4, 5 caveat? Right-hand side, which rule you applying? There are 1, 2, 3, 4, 5 rules, isn't it? Which rule you are applying? Oh, actually, more than that, there are 3 dots. You also need to do a 3 dot. Which one? Simplify the more complex side, correct. But how come then you can say the right-hand side is a complex side? In right-hand side, I only have one expression, isn't it? In left-hand side, tan squared theta plus 1. So which side is more complex? Left-hand side, isn't it? Are you following that? More complex mean more terms. So let's take the left-hand side, and I'm going to apply what Gauss is said. So Gauss is said, express all the tan and sine over cos, isn't it? So Harsha, what is the expression for tan squared of theta? Let's say another expression for tan squared of theta in terms of sine and cos.
Sine squared theta divided by cos theta.
Sorry? Sine squared theta over cos squared theta, right? All right. So now how do I show that to secant square of theta? Do you guys know boomerang? Who know boomerang? Do you know boomerang?
Everything you throw.
Yeah. I need to use a boomerang in the class. It'll come back to me. What do you see? Nice weather? Sunlight coming in? Okay. All right. I'm just asking a question. What should I do now? I'm stuck. How do I do the secant square of theta? Who can tell me what? Yes.
You return to 1 plus tan squared theta.
Well, that's going from, I used to tell a story. That's what is given to us, sir. Right? Okay. What he said, I like to tell a story. So one day, 2 cats got a roti. So they want equal share. So they went to the monkey. So monkey find a weighing machine, split the rotis and put it in here. And when I put it, this went up, this went down, this went up. So what monkey did, okay, you want an equal share, monkey buy this piece. Monkey buy this piece. So now this way, this went up and this come down. So monkey was keep on biting to balance it. At the end, no roti left. This is applied in 2 places. Those who have taken chemistry, you might have seen that in balancing equation. You try to put some number there and then you change it. You put some number here that change it. Don't you guys feel that in chemistry? When you try to balance it, you put the 2 oxygen and then suddenly you got a 4 oxygen here. Okay, to fix the oxygen, you put a 4 here, the hydrogen change it, isn't it? Similarly, in trig identities, we will end up with same identity again, right? So we don't want to do that. Yes, he's right. Sine squared of theta over cos squared of theta is tan squared of theta, but I don't want to do that because that is where I'm coming from. There's no point for me to go back to the same expression, right? So then what I can do? What is your first unit you have learned at school?
First one,
Mm-hmm.
trigonometry.
Okay. I don't think that you learned domain and range first. Your
Oh,
first,
factor.
huh?
Factor.
Yes. And then from factoring, where did you go?
One expression.
Oh, simplifying expression. And what kind of expression you simplify? There's a name for it. Simplifying. Rational expression. Do we have fractions here? Sine squared theta over cos squared theta, isn't it? Do we have a fraction? How do I simplify the fraction? Say if I want to add two fractions, what I need to do?
Divided by the cos
What I have to do to add two fractions?
to add.
Yes.
You add the. You're adding the one.
Sine squared.
All I want to hear, sir. If I want to add two fractions, what is the first step?
Denominator.
Common denominator. Do we have a common denominator? Huh? Do we have a common denominator? How come? I got a cos squared theta, I got a 1. Do we have a common denominator? No. Then the common denominator is 1 times cos squared of theta, isn't it? Are you following that? So this one will be sine squared of theta. This one I need to multiply by cos squared of theta because I got 1 cos squared of theta, one became cos squared of theta. I mean, that's need to be multiplied by cos squared of theta. Now what, Harsha? What did you see?
There's two percent.
Two. Oh no, you cannot. No, you can't. You can only cancel it with its factor, but there's a plus sign in the middle. So what Harsha said, you can cancel the same expression, but you can't do that because cos squared of theta, you cannot cancel it. It is not factored. It's sine squared of theta plus cos squared of theta, so you can't. So what should I do next? I want to show that it took a secant squared of theta stack. What should I do?
Sine squared theta plus cosine squared theta is 1.
Correct. We just finished learning the famous trig Pythagorean identity that says I can replace this one by 1, isn't it? Have you seen that? Yes? Did we learn that today? Sine squared of theta plus cos squared theta is equal to 1. Okay. What is R that a 1 over cos squared of theta is? %. If Ontario Institute of Studies in Education paying me, I'm going to do my research. I really need to find out. We have to fix it. Yes. Secant squared of theta is a reciprocal. 1 over cos is reciprocal of secant, isn't it? Are you just following that? You all good? Which is on the right-hand side, isn't it? Now, you guys going to be wondering how to do this. There is no magic. Trig identities, you have to practice tens of thousands of practice. But will your teacher is going to put some difficult one? Not necessary. There will be some easy one, but depends on the grade. For Kaja, for sure, you're going to find a difficult one. So only way you can do it if you really practice it. Are you guys following what we have done so far? We take the left-hand side. We're playing a TV game. Who played Tetris? Anyone play? Okay. So in Tetris, what's happened? You got either this kind of shape comes in, either this kind of shape comes in, either this kind of shapes comes in, isn't it? Or either this kind of shapes comes in. What do? You keep on changing it, isn't it? right? To make it flat. Exactly what I'm doing it. I'm keep on changing it. But when I keep on changing it, I'm substituting back something equal. All right, let's go back to the next one. Are you guys ready? So as I show that, why don't you guys do this one for me? See, take the left-hand side, same idea to prove that equal to right-hand side. So can you guys take that and prove it? Same idea. You're gonna change same way, changing the sign to, I mean, cotangent to sine over cos over sine, right? Yeah. 1 second. Divya, are you working on that question?
Yeah.
Okay, yes.
As in this one, or it cannot be the same.
Which one?
This one, like this part as this one, or no, because it's
No, so, no, they are same, but we are proving it. So this is already given to you, but we try to prove it in another way. But you're right, that is what he exactly said. That's given to us, but that's not proving, right? So we need to prove it. You done? But here's the problem. Cotangent is not sine over cos, it's cos over sine. And you can write that step, right? Yeah, you got that right. You done, sir? Thinking?
See it the first time.
You didn't follow the step. They say anytime you find tan, oh, you are on the sine over cos. Okay, keep going. You're right. You done, sir?
Yeah.
Correct. How about you? This is correct, but it's 1 over tan. So if you write sine over cos, that is actually tan, but you want 1 over tan. So that's need to be flipped. So let's see how to get started with. Correct? Yeah, keep going. Yeah, that's the right track. All right. So left hand side, 1 plus cotangent squared of theta. Well, some of you write 1 over tan, that's fine. But you should know that is cos squared over sine squared, isn't it? because it's reciprocal of tan, right? Makes sense? You can go by 1/tan, but then in the additional work you have to do. Kasha, you seen that? Oh, you got it. Okay. Now, what is the least common multiple? Sine squared of. What is sine squared of theta plus cos squared of theta? Is 1. So 1/sine squared of cosecant squared of theta. That's on my right hand side, isn't it? All right. Next one. The question for us is, this is left hand side. This is the right hand side. Which side should we work with, right or left? Let's go back to Divya. Divya, which side should I choose to work with, left side or the right side?
The right side,
Why?
because it has more ratios.
Correct, more return. Can you guys take the right hand side, replace the tan by sine over cos, and try to get the left hand side? Take the right hand side. Replace the tan by sine over cos. And let's see what will happen when you do that. You done, sir? Easy to prove? You guys know this guy? How many times I need to run that man? Who else know his name? Huh? Ramanujan. How many of you know Ramanujan? Only 1, 2 people. Let me bring a book he studied. Yes, I'm gonna bring a book that he studied. to ask you to do a search. Find out online how Ramanujan masters his mathematics in early years. Ask online how Ramanujan mastered his mathematics in early years. If you have a phone, you search it. Otherwise, I will search it in front of you. Yes.
I think you told me
You know the story, sir. So this guy remember the story, so he's gonna spoil us. All right. Let me going back. If you have a phone that you can search, otherwise I'm gonna show you how Ramanujan mastered his math in early age. So let's do that. So how a child prodigy by age 11. He had exhausted the mathematical knowledge to college students who were lodgers at his home. He was later lent a book written by Essaloni on advanced trigonometry. He mastered this by age of 13 while discovering sophisticated theorem on his own. Open the book and then see what you see. Open the book, check something on the front, something on the front, all the way on the front, and then you might need to read it to see is anything that I said is there. Anything I just read it is there? No. Okay, let's pass it. Let's see who can catch this. Anything that I said here is there? Let's see. Who has the good observation skills? No? Okay, pass it. Anything I said, I just read it. A child prodigy by age 11, he has extorted the mathematical knowledge of 2 college students who were lodgers at his home. He was later lent a book written by Essaloni on advanced trigonometry, and so on, so on, so on. Okay, pass it, sir. Like, you don't need to. On the front, there is some information. I read it there.
you said read.
Front page, there's some information about what I just read it there. Too late. Pass it. Pass it, pass it, pass it. Anna, pass it. I say pass it. Okay, Kavya. Some information I read in the front page. On the front page of the book, on the first page of the book, some information I read it. No, there's some information I read it right now. It's actually on the book. Serious boring.
What were you just reading?
A child prodigy by age 11, he has extorted the mathematical knowledge of 2 college students who were lodgers at his home. He was later lent a book written by Essaloni on advanced trigonometry. He mastered this by age of 13. How do you know?
Science trigonometry by Essaloni.
Exactly. This is the book written by Essaloni, which Ramanujan masters. Ramanujan, actually dive into trigonometry and geometry after practicing this textbook. This textbook is written in 1800. So S.L. Loney is a professor at Cambridge or London. If I'm right, yes, he's a professor at Cambridge, wrote this textbook. Now, what? Oh, how much this book cost you? Do you know how much this cost when I bought it? This is less than $2 or $3. Right now in Canadian currency, $3. You can see the price, 2,000 rupees. So it's Indian rupees on those days. Now, why did I get Ramanujan book? When we learn trigonometry, we have to write competitive exam. The only way to do well, practice everything on this book. We know our professors getting questions from here. Look like not a fancy book, but if you flip it, so much of trig identities sitting here. So why did I bring that book? Trig identities just by practicing it. The more practice, you will see the questions. How many of you are able to do this question? You did it. No?
Yeah.
You did it? Did you guys break the tan theta first? Okay. So sin theta times cos theta, sin theta over cos theta, isn't it? Did you do that, Kasha? Okay. Can I cancel these two? Did you guys do that? You did that. Okay. Then what is left over? Sin squared of theta, isn't it? Can I write that therefore is 1 minus cos squared of theta? That is equal to my left-hand side. Because sin squared of theta plus cos squared of theta is equal to 1. 1, isn't it? Can I then say sin squared of theta is equal to 1 minus cos squared of theta? Can we do that? Yes. We're doing easy one. We didn't go to difficult one, chat. We are just doing the easy one. The difficult ones are coming here. Just checking how difficult it's going. Yeah, so I try to finish this so we can go back to sine law and cosine law next class. So far so good. All right. How many of you learned trig identities already at school? Did you come to this unit yet? No. How far? Just bravely done. You done? All right. Did I do this question before? I didn't. How did you? I didn't do this? Huh?
It's similar to the question you asked if they were same to one of the identities.
Yeah, I proved that in the beginning. That's the first thing, even before I introduced trig identities, I did it. Even before I doing something, did I ask to prove this? Yes. We already did that question, isn't it? All right. So that we're gonna go back to this guy. So Harsha, we got a left side, we got a right side. Which side we should choose? Right side. Why? More complex. All right. So can you just complete that? Change the tan theta or sin theta or cos theta. And then I would like to see Pavia if you can send this proof to my chat on on WhatsApp.
Okay.
So
Done. You prove it. All right. Should be an easy proof. Did you know how to work with Rachel Let's questions? You didn't prove that is equal to cos theta, sir. You have done this part. The bottom is not right. You got to show at the end is equal to cos theta. Why did you go upstairs? What's happened? Huh? So what does that make you to go up?
So you make sure.
Make sure what? Okay. Let's see how Divya has done it just before I check it. All right. Are you waiting for that? You done, sir? You done? Yeah, that's right. How far you start with? Okay, you rewrite that correct. So that is correct. But if you multiply the sine times sine, what did you get? How come sine times sinus? X times x is?
So just
Well, what?
square.
Exactly. Then you should be able to see they have a common denominator. How do you show that a sine square theta right away? You see that sine of, sure, it's not sine times sine. You're missing an angle. Who's going to put the angle? Sine q, cos q. Where's the angle, sir? Cos theta sine. You can't miss the angle. How do you think that? You're confused. Did you change that tan theta to sine theta or cos theta? Why? We're gonna be stick with that. We're gonna stick with the rule. We're gonna convert all the tan back to sine over cos. What are you doing, sir? After that, you're going a long way. So sine times sine is what? Yes. And then you can see there's a common denominator for both terms, isn't it? All right. So 1 over cos theta minus sine theta times sine theta over cos theta, isn't it? What is sine theta times sine theta? Sine squared of theta over cos theta. Good news is we have a same common denominator, isn't it? So I can combine them 1 minus sine squared theta over cos squared of theta. We know 1 minus sine squared theta is cos squared of theta, isn't it? And my bad, on the denominator, I put cos squared of theta. It's supposed to be cos theta. Which is on my left-hand side, isn't it? Are you following that? Yes. All right. Then it says trig identity 2. You should have a textbook. If not, you are in the Google Classroom. You can practice those questions. Again, trig identities by practicing it. So we already talked about all these identities. So this is basically summary of them again. You all know this. Same thing. There's nothing new. But what we're going to do, we're going to going back to a couple more different ones. So a little complex one. So what I want to do is, there are a complex one, but let's going back to some difficult one to prove. I don't want to go to the easy one. We already did this tan squared of theta plus cos squared of theta. Let's go to the B. So either way, there's a left-hand side and a right-hand side. Which side should I choose to prove? Left or the right? Why? More term. So left-hand side is sin theta over cosecant theta plus cos theta over secant theta, isn't it? Now, all I'm going to do, I'm going to rewrite my reciprocal ratios back to the real ratio. Sine theta over 1 over sine theta plus cos theta over 1 over cos theta. Dividing by sine is multiplying by sine. The sine theta will go up, isn't it? This sine theta will go up. That cos theta will go up. What is sine square theta plus cos square theta? 1, which is on that right hand side. So, Divya, your teacher skipped that exponential functions unit?
I think we're doing it after periodic functions.
Okay.
Yeah.
It's the best way to scare people. How's your class doing with the trigonometry?
I don't know how we did, but the test was pretty like good. But I know the class average is like a 68 or something, so not that good.
All right. So now let's going back to something cool, difficult. So I'm going to go backwards. So I did this one. This is easy to prove. Change that tan theta to sine over cos. Very similar to something we have done. All right. Let's going back to this guy. So if you're going back to this guy, which side caveat should I take it to prove? Left side or the right side? Left side. So here's what I want you guys to do. Take the left side, find the greatest common fact, least common multiple, simplify that expression, you will get the right side. What's up? Take the left side, find the least common multiple for those denominators, because you should know how to do that. You got 1 plus sine theta, 1 minus sine theta, isn't it? Least common multiple, in this case, product of those two, right? So can you guys simplify the fraction? And then you will see the answer coming in front of you. If you take the least common multiple for 1 over sine theta, so what is the least common multiple for 1 over sine theta and 1 over 1 minus sine theta? Let's do this. Let's going back to, okay, don't do this. I'm going to give you guys a question. 1 minus x plus 2 over 1 plus x. Can you guys simplify this, please? Simplify this expression. 1 over 1 minus x plus 2 over 1 plus x. All I asked to do, something you have learned in your school on the first day or the second day or the first week. Where is it, sir? Oh, you're working on a question. Let me see.
I can't do it tonight.
You want a pen, sir?
I think.
Here we go. Done. See? Well, you already proved that. Yeah, that's right. But I asked to simplify. You done? Let me see your work. Yeah, that's right. All right. And couple of you add 1 plus 2 and then 3. So basically what you're doing is if I have 2 over 5 plus 1 over 7, you're writing it 3 over 35. I really need to do a research. First of all, to add 2 fractions, you need to find the least common multiple. And you have a 1 minus n 1 plus x, as least common multiple is 1 minus x times 1 plus x. This one, therefore, need to multiply by 1 plus x. This one need to multiply by 1 minus x. So that is 1 plus x plus 2 minus 2x over, this is 1 minus x squared, which is 3 minus x over 1 minus x squared. All right, guys. So we will going back to trigonometry identities. I know that anyone who's going to be see the math going on, you will come back to that at this point at school. You got a good questions on trig identities. What would you do, say, if you get stuck in proving that?
Search it up.
Where would you search it up?
ChatGPT.
Thank you. You can ask ChatGPT for just giving you the steps. It will tell you detailed steps. You get stuck. You have a tutor in front of you. But what you guys do, you use the ChatGPT to do your English essay, but you're not going to use it to write the math or do the math. That's what people do. You guys use the ChatGPT for completely wrong purpose. But to do the homework purpose, no. I teach tech design. They're designing something on Canva. They need a picture from Canva, put it on a slide. The kid asked me, "Sir, how to get this picture from Canva to go to the Google slide?" He said, "YouTube it." Kid will come to me, "Sir, how to change this color in this?" YouTube it. My tech design class, I don't teach. I give a project. When they ask, search it online. Yes, search it online. You need to learn things in the technology world. You should know how to search things online, follow the instruction. All right, so I will tell a couple of your parents that trig identity is going to be taking a toll, what you have to do. All right, Tavia, see you next week.